specific latent heat. Think about this experimental arrangement. You have a container in which you have ice at negative 10 degrees Celsius. And you put a heater here, and then there is a temperature probe connected through a data logger to a computer to measure the temperature. And then what you do is you just start heating this. Now, when you increase the temperature, it starts from negative 10, and then the temperature increases, and when it goes to 0, something peculiar happens. Although you keep on heating, the temperature does not increase. It will remain at the same level for a little while. What's really happening is the amount of energy that you produce is being used to break bonds and turn solid into liquid. So at the beginning here, everything is solid. At the end here, now everything is liquid. Now, once everything is liquid, the temperature will obviously rise again. So the liquid will heat up. And the same thing happens when it hits 100 degrees Celsius. At that temperature, now the liquid is being converted into gas. The vaporization is going to take place. So again, the change takes place and it requires energy. So the temperature does not rise. So what happens in places like this is called a phase change. So specific latent heat is divided into two categories: specific latent heat of fusion, where the solid is turning into liquid, and specific latent heat of vaporization, where the liquid is turning into a gas. Let's take an example to understand this in depth. So you have 1 kilogram of ice at 0 degrees Celsius, and you need to convert it into 1 kilogram of water at the same temperature. So you can see the temperature has not changed. Remember, the graph was flat. Now, this process requires 334,000 joules. Now, this is an experimental thing. So the definition of specific latent heat of fusion is the amount of energy needed to convert 1 kilogram of a solid at its melting point to liquid without changing its temperature. So we can say specific latent heat of fusion of ice is 334,000 joules per kilogram. Think about 1 kilogram of water at 100 degrees Celsius, which is the boiling point of water. Now, if you want to convert this to steam at the same temperature, so from liquid to steam, the amount of energy needed is 2,260,000 joules. So the definition of specific latent heat of vaporization is the amount of energy needed to convert 1 kilogram of a liquid at its boiling point to gas without changing its temperature. So we can say specific latent heat of vaporization of water is 2,260,000 joules per kilogram. The formula for specific latent heat is E is equal to ml. E is the energy in joules, m is the mass in kilograms, and L is the specific latent heat in joules per kilogram. And you can use the same formula for both fusion and vaporization. Here's a question for you to try. Please pause the video and give it a try. Press play when you are ready to see the answer. Part A is very straightforward, just direct substitution. E is equal to ml. Mass is 0.5 kilograms. It's really important that you convert grams to kilograms. And L is given, and the answer is 167,000 joules. Second part, explain why the temperature of the ice does not change during melting, even though energy is being transferred. For 1 mark, you need to mention that the temperature remains constant during a change of state. For the second mark, you need to explain that energy is used to break intermolecular bonds and not to increase temperature. So, in a solid, the particles are like this, pretty close to each other. So, energy is needed to separate them to overcome the forces and turn it into a liquid.